Okay, guys, welcome to this quick video where we're going to take a look at question 5 of the mock exam from WIS5 to look at how do we deal with differential equations that have a homogeneous side and a non-homogeneous side. To begin, we need to recognize that is the case in this question, and we can really easily see that this is homogeneous and this side is non-homogeneous. But how do we deal with that? How do we deal with having two different types of variables? Well, we need to split them up. And if you look at your formula sheet, it talks about solving the homogeneous side and the non-homogeneous side and combining them to form the general solution. So this means that f of t is the sum of the homogeneous side plus the non-homogeneous side. So this is going to be our left side and this is going to be our right side. Now, let's start solving. So I'm going to look at the left side first, which is our homogeneous side. We can see that, and we can look at this equation again, and we can see that it's d2y divided by dt minus 2 times dy by dt plus y, and we can set that equal to 0. Now we can see from the formula sheet tells you this, but you should know that when we're solving this kind of thing, we want to put it in the form of lambda. So we can say, and this is equivalent to lambda squared minus 2 times lambda plus 1 equal to 0. And now this is just a normal binomial equation. We can solve this using binomial expansion or using whatever your favorite method is. I'm going to set it out as if we're going to do it with binomial expansion. So we can say, well, A is clearly 1, B is minus 2, and C is 1 again. And we're solving this in the form minus B plus minus the square root of B squared minus 4 times A times C, all divided by 2 times A. And if we solve this, you can also maybe see it intuitively, we will get two forms of lambda in which lambda is 1. So lambda 1 equals 1 and lambda 2 equals 1 also. When we recombine this to form our homogeneous general solution, that means we can get it in the form f of t is equal to c1 plus c2 times t times e to the power of t. This is obviously because lambda is 1, and I've subbed this in as writing this, so there's no need to write anything else. Now when I look over at the right side, what I'm looking at here is using that bottom section of the formula sheet. That bottom section talks about how do we deal with this right side. And the first thing to do is to realize what form it's in. And we can really clearly see that it's 2t minus 3, which means that it's in the form where r of t equals a times t plus b. Now the important thing to note here is that a does not just equal 2 and b does not just equal minus 3. We need to do some substitution to actually calculate this. What I need to do is I need to substitute r of t as if it were y. That's how I know that they're going to be equal. But I have y in several forms. I have y as a normal form, I have it as the first differential, and I have it as a second differential. So I need to calculate what are those values. So first thing I'm going to do is I'm going to differentiate it once, and that equals a, because we're differentiating with respect to t, which means that b goes to 0. It's t to the power of 1, so we times a by 1, and we take 1 from the power of t, which means that we're left with just a. If we differentiate that a second time, then we're left with 0, because we have no values of t to differentiate. Now I'm subbing these three back into our original equation, which was the second differential. So what we're substituting in is 0, minus 2 times the first differential, which we're substituting in as a, plus the normal equation, which is a times t plus b, and that is equal to what we have at the top, which is 2 times t minus 3. Now we're just going to solve this equation and try and work out the unknowns. So we have minus 2 times a plus a times t plus b equals 2 times t minus 3. Now what immediately jumps out to me is we have only one value of t on each side, which means that the coefficients have to be equal. This means that a is equal to 2 because there's nothing else, there's no other coefficient of t which would add up. And now I know that a equals 2, I can sub this back in, which means that we can say minus 2 times 2 plus 2 times t plus b equals 2 times t minus 3. And that gives us 2 times t plus minus 4 plus b equals 2 times t minus 3. Again, looking at the coefficients, we have these two which must be equal, which means that therefore minus 4 plus b is equal to minus 3, giving our value of b as 1. Now I know that a is 2 and b is 1. I can sub this into the form of at plus b. So r of t equals 2 times t plus 1. Now when I combine these, to form the general solution, that means I get f of t equals c1 plus c2 times t times e to the power of t plus 2 times t plus 1. And this is the general solution. Without boundary conditions, which they may or may not give you in the question, you cannot calculate C1 and C2 because you need to know that, for example, at a certain time causes a specific value of the function. So this leaves us with this answer, which is correct.